All right, guys, so we've done factoring of just quadratics and walked through a couple of techniques that work really well for those. We're going to be factoring polynomials now, meaning any degree, any number of terms. And so we're going to start with this first pattern called the sum and difference of cubes, which I think some of you guys have seen before. I'm going to write down the pattern first, just kind of get them out in front of us, and then we'll walk through some little tricks that you can help to remember which one is which. So the sum of cubes looks like this. Okay, and then the difference of cubes looks like this. Okay, so we're going to walk through some patterns that will hopefully help you remember. So first thing I want you to notice is that with the exception of the signs, they're identical. You've got A's, B's, A squared, AB, B squared. Everything is identical except for the sign. Okay, so this middle sign right here, the last sign right here is always positive. So that's one thing you can hopefully see there, is that for both of them this is a plus, and then these two are switching. So this sign right here is always positive. This sign right here and then this sign right here have different patterns. So this sign right here matches this sign over here. All right, so this is the same as the original. Same as the original, and then this middle sign is the opposite of the original. Okay, so same, opposite, and then always positive. All right, same, opposite, always positive. You can use the word soap to remember that. All right, same, opposite, always positive. And then if you can have this pattern memorized. So this goes from a cubed to b cubed. We drop down to just an a and b. Then we square the first term, multiply the terms together, and then square the second term. And we'll kind of go through that pattern. We're going to practice a few of these. So we are going to walk through this example, factor the polynomial. So these ones, we are hoping that they're the difference of cubes, and we'll see what happens here. So the first thing you do every single time that you're factoring is you look for a GCF. If you have a GCF that can come out first, a lot of times it'll make things simpler. So this one, there's nothing that x cubed and negative 400 have in common, so there's nothing that we can do to simplify that any further. So we can tell, obviously, that the x cubed is a perfect cube. What we don't know is whether the 400 is a perfect cube, so we're going to try to think and see if there's anything that we can multiply by itself 3 times that would give us 400. And there actually is not. 400 is a perfect square. It's 20 squared, but it's not a perfect cube. So this is actually an example that turned out to be prime, and that is because this is not a cube. This is a cube, but this is not. All right, so let's look at this next one. Again, as always, start with a GCF. So if we look between these two terms, I can tell you first they both have a 3. So 24 is a multiple of 3. And then they both have 2 copies of x. Okay, so I'm going to factor out a 3x squared, see what's left. So here I have 8, and then there's an x cubed left over, plus here I lose the 3 and the x squared. I'm left with just a y cubed. Okay, so this is our first example that we're actually seeing of this pattern in action here. So let's walk through and I'll show you how to best set it up. So don't forget with this one that you are still going to have that 3x squared out front. It doesn't disappear. We just kind of hold its place out front since we factored it out. Now, this is a cubed according to our formula. And this is b cubed. So the first thing you want to do so that you can fill in all the spaces, b cubed is y cubed. So that means every time you see a b, you're replacing it with a y. All right, so that one's easy enough. A cubed is 8x cubed. So if you're trying to figure out what a is, it's like, what did I multiply by itself 3 times to get 8x cubed? Well, the cube root of 8 is 2, and the cube root of x cubed is x. So if I take this and multiply by itself 3 times, 2x times 2x times 2x, I will get 8x cubed. Same thing with y. Y times y gives me y cubed. So every single time I see an a in this formula up here, I'm going to replace it with a 2x. Every single time I see a b, I'm going to replace it with y. Okay, so don't forget about your 3x squared. Since this is the sum, right here I guess, we're using this formula. So we start with a plus b. So I write 2x plus y. Okay, and then a squared. So I'm going to take this term and square it. 2x times 2x, and I get 4x squared. And then minus, because this is the opposite sign now, a times b, 2x times y. And then plus b squared. So then I take this term and square it. So I get y squared. And that is actually as far as we can take it. All right, so it looks like it's a little more complicated, but it's actually a good thing, excuse me, because we're going to try to solve by factoring in the next video. All right, so here is a handy little chart that we can use, and we're going to continue to use through the rest of this video. Kind of walks you through different factoring techniques. So this is the one I mentioned. You should always look for a GCF first, always, always. And then we've got 3 different patterns if you have 2 terms. We did the difference of squares already. Note that there is no sum of squares. There is no such thing. We just learned these 2. 3 terms, we did this a while ago when we were doing polynomials. And then 4 more terms we factor by grouping. So we're going to learn how to do that right now. So the way that we factor by grouping is we split into 2 equal pieces like this. Okay, and I think we actually have done this before. So we look for the GCF in each group. So the first group that I have underlined here, they both have 2 copies of x. So my GCF is an x squared, and I can factor that out. I am left with an x plus 5 once I do that. Next, a negative 2x minus 10. My GCF would be a negative 2. And I'm again left with an x plus 5. So remember the way we're supposed to treat these is like this is one term and this is one term. What those 2 terms have in common is an x plus 5. So I can factor out the x plus 5, and then once that is gone, I am left with an x squared minus 2. All right, once you come up with a linear term, you know you're done. We have a quadratic term, so that might factor further. Let's see if it fits the difference of squares. X squared is a perfect square, but 2 is not. So we actually can't factor that any further. If it were like an x squared minus 4, you could take it a little farther. Okay, next, we are going to split into 2 even groups and do the same thing, factor by taking out a GCF. All right, so these are all even. And actually, they're all multiples of 6. So I can take out a 6, and then all of those terms have an x. Okay, so I'm going to factor out a 6x. Here I'm left with a 5a. Here I'm left with a negative 4b. And here I'm left just with a c. Okay, so let's look at this next group. Next group, I've got a negative 5ay squared, 4by squared, negative cy squared. So in order to make sure this matches, I got to make sure I take out a negative, and then the only thing they have in common is a y squared. Okay, so again, I had to take out a negative so that this would be a positive 5a to match this positive 5a. And then when I divide out a negative y squared here, I'm left with a negative 4b. Whoops, not done yet, sorry. And when I factor out a negative y squared here, I'm left with a positive c. Just ignore this, I was starting to close the parentheses early. So just like up above, this is one term, this is one term. And we can factor out the GCF, which in this case is a 5a minus 4b plus c. And then my leftovers, 6x minus y squared. Okay, so that is completely factored down. Nothing can go any further than that. Okay, another one here. We got 6 terms, and this is an important note here. It's the only method that you can use if you've got 4 or more terms. So we see more than 4 terms. We know we're at least starting with this method. We might use different methods as we keep going. So this first group that I've got underlined, every single term has a y cubed. I can start with that. I'm left with an x squared minus 3x plus 2. And then this next group that I've got underlined, every single term has a z cubed. So I can factor that out. And I have an x squared minus 3x plus 2. All right, so notice, just like the ones up above, we've got the exact same thing in parentheses. So I can start by factoring that out. Okay, and I'm left with the y cubed plus z cubed. When we are factoring, you make sure that you cannot factor any further. Once you can't factor any further, then you call it your final answer. This one's a quadratic, so I can actually keep going with this. I can start by making this x and x. And then what multiplies to positive 2 and adds to negative 3? That would be a negative 2 and a negative 1. So I'm done with that piece. This right here is the difference of, the sum of cubes. So in my formula, a is y and b is z. So the first part is just a plus b. so I just write y plus z. Then a squared, so y squared, minus a times b, so y times z, plus b squared, so plus z squared. All right, and as lovely as that is our final answer. We've got one more similar problem here. This one, 64x to the 6th minus y to the 6th. I can either treat this as the difference of squares first or the difference of cubes. We're more familiar with the difference of squares, so let's start there. We could do either one though, like I said. So here and here to give me 64x to the 6th, that would be 8x cubed. 8x cubed. And then to get y to the 6th, we'd have a y cubed. And then you know the difference of squares pattern is always 1 plus 1 minus, so that the middle term cancels out. Now, this is the sum of cubes. This is the difference of cubes. All right, so for this one, a is a 2x. If I cube a 2x, I come up with 8x cubed, and then b is y. And it's actually the same exact thing here. I just have a different formula. So a is 2x and b is y. So for this first one, I start with a plus b, so 2x plus y, a squared, so if I square 2x, I get 4x squared, minus a times b, so 2x times y, and then plus b squared, so plus y squared. Then I move on to this next one. Very, very similar, I'm just switching the signs. So since this starts with a minus, this one starts with 2x minus y. Then a squared is still 4x squared, but I switch my sign to plus. Then I multiply these together, I get 2xy, and then remember the last sign is always positive. So again, even though it seems like this is getting way more complicated, we need this when we move on to the next section because we're going to be solving. All right, guys, I started making this video and then an announcement came over the PA, so some stuff is already written. So I'll kind of walk you through what I've got written here. So it states that small cube is cut out of a larger cube, so we should know what the volume of a cube is. Volume of any box three-dimensional shape is length times width times height, but if all the sides are the same, it would just be like side times side times side, which is side cubed. Okay, so that's what we're working with here. And we've got this large cube, which has a dimension of x, and then we're cutting out a smaller cube. So the volume would be x times x times x, which is the volume of the larger cube, and then we're subtracting away the volume of the smaller cube because that's being cut out. So this will be the volume of that strange shape, and we were told that it was 23,625 cubic centimeters. So that's the first equation that we can set up. Second equation we can set up, is what I have underlined here, and it says the length of the smaller cube, which is y, is 1/2 the length of the larger cube. So that's this equation right here. Rather than dealing with fractions, which I'm sure a lot of us don't want to do, we can multiply both sides by 2 here, and we can get 2y equals x. All right, so what we're going to do with that is we're going to do a little substitution. We're going to take this right here and sub 2y in for x in that equation. Okay, so for the volume, instead of x, I am going to write 2y cubed minus y cubed equals 23,625. Okay, so with that equation, what I am going to do is simplify this up right here. So 2y cubed is 8, like 2y quantity cubed, we get 8y cubed, and then minus y cubed gives us 7y cubed. So we're just solving this equation at this point. All right, so we're trying to get the y by itself. So we're going to divide both sides by 7. So when we divide both sides by 7, 23,625 divided by 7 leaves us with 33,75. And then what we do to get the y by itself is we cube root, because this is being cubed, so the opposite is to cube root. It's just like squaring and square rooting. So let me show you that button on the calculator. See next to the square root. The square root is in blue, and then it says n root x. So hit Control and then hit that button. And the root that we're taking is the third root, and then hit Tab, and we're taking the third root of 3375. And what we come up with is 15. Okay, so y equals 15. That would be the length of the smaller cube. And then it says that x is twice that. So x would be 30. And we want units, they're both centimeters. Okay, so those would be your dimensions for the first one. The last thing we're doing, and this is a pretty brief video here, the last thing we're doing is something called quadratic form. Quadratic form is any expression of the form a u squared plus b times u plus c, where u is an expression of x. Okay, so you'll see what I mean once we start looking at this example. So example 5, it's going to kind of look like it's in quadratic form. So this middle term is supposed to be b times u. So that means in this case, our expression of x is an x cubed. So I can write this by taking the 2 out fronts, and then the x to the 6th is x cubed squared. Okay, we're kind of using those exponential properties to rewrite that. And then minus x cubed, and then plus 9. So see how I've got these terms in parentheses? Those become like the u right here. So we've got a u squared minus, and then b, so we could technically have like a 1 b times u and then plus c. So that is what we mean by quadratic form. So kind of writing it in a way that you could factor it with your normal quadratic rules. All right, this one. We've got x to the 4th. So if we say that our middle term, because whatever's in the middle here, that's always just going to be u. So u squared should be x to the 6th, but this isn't an x to the 6th. So this is not possible to write this in quadratic form. So whatever this term is right here, it should always be this term squared. And if I square an x cubed, I get an x to the 6th, not an x to the 4th. Okay, so we're going to go through an example of solving by using quadratic form. So this one, my x squared, that's my middle term, so that means u equals x squared. And if I square that, I get x to the 4th, so this is in quadratic form. So let's write that. So x squared squared, that's what I can write for x to the 4th, and then minus 29 x squared plus 100 equals 0. Okay, so just like I solve my quadratic equations, when I have 0 on the right, I can factor this down. And once I factor this down, then I'll be able to solve by factoring. So I start with my 2 pieces here. Okay, instead of being x and x, it's going to be x squared and x squared. So if I multiply these two together, I get x squared squared, which is what I'm supposed to have right here. And then I want to multiply to 100 and add to negative 29. And that would be a negative 25 and a negative 4. Okay, so now that I've got it factored originally, I can actually keep going because both of these are the difference of perfect squares. So this, I can start with, again, x and x. I can do the same thing with this one. Start with x and x. Okay, here, to get negative 25, I have negative 5 and positive 5. That's the difference of squares pattern. Same thing here, negative 2 and positive 2. Okay, so now I'm going to get 4 answers. If I set each one of these equal to 0, if I set x minus 5 equal to 0, I get 5. If I set this equal to 0, I get negative 5. This gives me 2, and this gives me negative 2. So I've got 4 answers here. I think that's it. Yep.